This is a geometry model. There they are. Oh, I have it somewhere. Alright, so, good morning. It is a wonderful day today in the pre-calculus class. Mainly because I get to eat Smarties. Okay? You know, it's a good day. I do not have your test corrected. Good. The stack of papers that I cut those all the homework packets last night, the stack that I took home was like that. I maybe got through not probably about that much. But I did the homework because that was an easy grade. So we got that going on. Okay? It is progress report time. And so for me, I'm sure Mrs. Hill is going to be the same way. Kind of wherever you're at, that's where we're just going to send it in progress. And so your test won't be on there. Homework will be, but your test won't be. So that's where we're kind of at today. And unfortunately, you don't have the portal right now because it's closed for us, teachers, to put grades in. So if you have questions about what your grade actually is, see me or see Mrs. Hill. So, okay. The reason that it's really a good day today is we're going to start trig. Okay? And trig is the backbone and the nervous system and the organs and pretty much everything of the body of this class. And this class is all about trig. So far, we've been refreshing our algebra so that we can use that algebra in trig. Okay? So that's why we've been doing that so far. But now it's go time. Okay? So we are going to start chapter 4 today, which is trigonometric functions. Now, mathematicians, by their nature, are quote-unquote lazy. Okay? And what I mean by that is, if there's a formula, we're going to use that formula. If there's a shortcut, we're going to use that shortcut. We make up shortcuts to make our lives easier. Okay? Solving a 3x3 system of equations is much easier using matrices than it is doing it using a substitution. Okay? And that's why we kind of go through and do that. Okay? So a trig function, and the reason, so when you hear us say trig, we're talking about the field of trigonometry. Okay? And so a trig function has an angle measure as its input, and the output is a real number. Okay? In algebra, which we've been doing the last couple of weeks, in algebra, the input is a real number, and the output is a real number. Okay? So in algebra, it's a little different. Okay? You input an x value, a number, and you get out a y value, a number. In trig, we're going to input an angle and output a real number. Okay? So we got that going on. Now, in trig, there are two different but yet the same measurement units, we'll say, okay? Styles, if you will. Okay? The first is degrees. Okay? Now, you want me to go back? Anything for you, Queen. I'm not that nice. Okay? So, the first is degrees. Okay? How many degrees are there in a circle? 360. Around a point, there's 360 degrees. In a circle, there's 360 degrees. Why 360? Anybody know? Why they chose 360? Well, why did they choose 180 then? You know what I mean? But why isn't 14 a straight line? You know what I mean? You got to think way back to whenever it is they were developing this. Why did they choose 360? Anybody know? Okay, good. That makes all of us. Or do you know?
Is it because the measurements that they could only be as accurate to get 360?
Okay, that could be a good reason. The only reason that I've really found is because it's sexagesimal. We'll go with sexagesimal, whatever. Okay, it's a base 60. Okay, but really, from my experience, the 360 is one of those nice numbers. And by what I mean by one of those nice, cool numbers is a lot of stuff can go evenly into 360. 2, 3, 4, 5, 6, 8, 9, 10. I think that for a minute. 12, 15, 18, 20. You know, all of those divide evenly into that number. And all of those then, you know, kind of we'll get into the unit circles, and you see some of the unit circles floating around the room yet. You know, bless you guys. We'll get into that, and you'll see that we're dividing up that unit circle into all those different parts. Okay, and so 360 works in that one. Okay, so if I was dividing up the circle into degrees, over here would be 0 degrees. Okay? Trig's a little goofy. Direction and bearing, 0's up top. But those are not trig. Trig, 0's out to the right. And then we go counterclockwise. So this would be 90 degrees. This would be 180 degrees. This would be 270 degrees. And then you have to think like when you're cutting a pizza into the wedges, you know, and then 45 degrees, 135, 225. Ooh, that's a bad 5. Bad 5. That's a bright 5. Exactly.
I didn't see it. Can you show me what it was?
No, I can't because I've already erased it. It was bad. No, mine was. It went like that. It was bad. Well, I don't know. It's not mine. Bad. Okay? So we got that. Okay? Now, last year, if you were in Algebra 2 Extended, you did a little bit with trig towards the end of the year. You did the unit circle and that kind of a thing. If you were in Algebra 2 Regular, you took your big toe and you dipped it in the pool to see if the pool was warm or not, and then you pulled it out and said, okay, school's done, I'm out. I'm going to the beach. Okay? You know what I mean? So, what we're going to do today is we are going to develop the second way of, or the second unit of measure in trig. Okay? And so what I need you to do is I need you to take out a blank sheet of paper, okay? And using your compass and your straight edge, what I would first like you to do is somewhere very close to the exact middle of your piece of paper, I want you to put a big old dot. Okay? So put a big old dot somewhere in the middle of your paper, preferably right on one of those lines, because all of you, I think, are using line paper. So preferably pretty close to or right on top of one of the lines. Okay? Alright? And then, using your straight edge, what I would like you to do is I would like you to just draw yourself a line going out to the right. So just draw yourself a line going out to the right. Okay. Now, I'm going to give you a packet of Smarties. Okay? Do not eat them just yet. Okay? Because we're going to measure today with Smarties. You guys thought I wasn't going to give you guys any. I was teasing. Okay? Okay? So, what I would like you to do is I would like you to unwrap your Smarties, but again, okay, you gotta pass it back. Okay? Unwrap your Smarties, but don't eat them. As I'm eating some. Okay? I want you to draw me a circle with a radius of 7 Smarties. Okay? So, how do you do that? You take, whoa, tap the brakes. You take your Smarties and you line them up along your line. So that they're nice and tight and touching and all that good stuff. You can't overlap yours, but mine get overlapped every once in a while. Okay, so you got a radius of 7 Smarties and then mark it. Okay? And then draw your circle using the compass. That's not 7 Smarties. Hmm? That's a diameter. But, oh, I see. You didn't go, you got to go into the middle so you can draw your circle, Eddie. Yeah, no, in the middle of your paper. Like middle horizontally and vertically. Got me? Okay? Everybody got their circle drawn? Well, I'm getting a sugar high up here eating Smarties. Uh-oh! You want new ones? Sure. I promise I was just eating out of them. Okay? Now, what I want you to do is I want you to measure around your circle using your 7 Smarties. Okay? Put it on top of this. Around your circle. Okay? So measure around your circle using your Smarties. So, whoa, tap the brakes. Get rid of that one. Okay? So, what you're going to do is you're going to start down here and you're going to measure around your circle using 7 Smarties. Okay, and then keep going all the way around your circle. Whoa, tap the brakes. Oh, grabbed the wrong one. So we're going all the way around our circle. Okay, if I go, there we go. Okay, now if I go back a page, there we go. Now it's about. I hope. All right. Come on. All right. So what did you guys come up with? How many times around the circle did you go? 6. And then did you have some left over? Okay. Now on mine, it's a little harder to do because my circles kind of can overlap a little bit. That's why I came up a little short. But how many circles or how many Smarties did you end up with at the end in this little chunk right here? You guys ended up with 2 Smarties in that chunk? You got like 5?
I got 3.
You got 3? Okay, you should have ended up with 2. Okay. More than likely what happened when you did yours, because you ended up with 5, did you go over with your compass, did you go over the top of your Smarties, or did you mark it and then just go right to that mark? Do you remember? Like when you put your Smarties down, did you, so like when you put it down, did you go over the top of your Smarties then? No? Okay, I don't know what you did. I can't help you. But you should end up with 2 Smarties. Okay? Now, let's think about that concept. So we went around, and we went around 6 radiuses, right? Because 7 Smarties was the radius of our circle, and then we ended up with 2. So that chunk that we ended up with is 2/7 of a radius, right? Okay. Anybody got a calculator out, or can get a calculator out quite rapidly? Phone or something like that? Okay. What is 2 divided by 7? 0.2857. Okay, so we went 6.2857 radii to get all the way around the circle, right? Okay, so my question to you is, what is a radius? Or not a radius, a radian. What is a radian? My highlighter out. This, we said, was a radius. Right? This, we said, was a radius. What's a radian? If it's the other unit of measure in trig. What angle?
The angle formed by the 2
radii. Okay. But how big is a radii, or a radius, a radian, excuse me. You know, the other one. How big is a radian? No. No. Or how can we, it's not 28. It's actually 57.3, but we'll get to that tomorrow. Okay?
2 of them.
No. Now remember, we're talking an angle, right? So where's the angle in this problem? In between the two radii, right? So my angle is right there. So a radian, which this is right here, 1 radian is that angle. So how big is that angle? In words, not in numbers. It's what? No. Because our angle's not 7 Smarties, or it's not 3.5 Smarties, right? But it's the angle that it takes us to get what? But I could have dropped a radius anywhere in there. Think about actually on the circle. It's the angle it takes us to get. What's out here? A radius. Okay? So a radian is the angle in a circle needed to get a length of 1 radius of arc. Okay? It's the angle that we need to get 1 radius of arc length. Okay? Now, in the last 5 minutes, I want you to extend that knowledge. Okay? So, using something else, okay, anything in the room, and I've got some whiteboard ones here. I gotta fix this one, but I got some whiteboard there. You can use anything to get yourself a radius. Okay? What I want you to do is I want you to prove that with a different sized circle somewhere in the room. Okay? That you will get 6.28 radiuses all the way around a circle. Okay? Because that's how the circumference circle was developed, or the circumference formula was developed. It's 2 pi times the radius. Okay? So try it. Use something in the room. Go.